Hello everyone, I hope you are doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is expression add operators, and it is a hard level problem. So if by the end of this video you find that this video was helpful for you, or if you were able to derive any value from this video, then do consider dropping a like on this video and also share your thoughts in the comments. Whatever, like any general thing you can share, or anything about the problem that you want to share, you can write it down in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video was actually helpful for you, and this video will be able to reach more people like you who want to keep solving new problems. So let us quickly begin with the problem discussion now. So this problem is actually hard in terms of implementation especially, and since the morning I was trying one approach, and that is why I was a bit late in uploading the video. So since the morning I was trying that particular approach, and I was constantly getting theory. So if I show you my summations, you see that I've been getting a lot of theories lately in this particular problem, and I'll also tell you why I was getting those theories, what was my approach, and why I believe that it would pass in this particular expected time complexity, but unfortunately it didn't. So at the end I had to change my approach, and then it worked. Now this particular problem says that we have been given a string s and it contains only digits, right? So it will be all digits. Now what we have to do is we have a target, so we have to insert these types of operations, plus, minus, or multiply, right, in between those digits somewhere, so that when the final value is calculated, it is equals to the target, right? And we have to print all such combinations, right? So for example, in this particular case, 1 2 3 is the initial string, and we want the target to be 6, right? So it can be like 1 multiplied by 2 multiplied by 3, or it can be 1 plus 2 plus 3. Both of these are valid ways, and both of these will result in 6, right? So this is a problem. Now the first question that I had in my mind was whenever a string like this is given, right, string with some operations, do we evaluate only from left to right, or do we follow the precedence of operators? So I did try this with some sample test cases, and I tried running it in the custom input, and I got my answer that we have to print the answers according to the precedence, right? So let me just also show you with some examples. So let's say this is the example itself. Now if I put 9, so if the string becomes 1, if the string becomes 1 plus 3 2 multiplied by 3, and if we directly evaluate from left to right, without thinking about the precedence, so what will be it will be? So it will be 1 plus 2 3, and 3 multiplied by 3 9. So right, there should be an answer, but that is not the case. If I show you, if I compile and run, you will see that this is not the case. So the only possible answer is 12 minus 3, right? Because 12 minus 3 would be equals to 9. So the way I was discussing is not in the correct answer. That means the precedence of operators is also very important. So this is something that you need to note in the particular question. So let me just start with the problem discussion now, how we can solve this. So I'll discuss my first approach before the second approach, because I believe that it should have passed the test cases, but unfortunately it didn't. So the expected time complexity is n, or it is s actually. This is the size of the string multiplied by 4 raised to the power size of the string, right? So this is our expected time complexity. Now let's say we have a string of some length like this, right? Let's say this is 5. Now there are actually two parts to this particular problem. The first part is to find all the possible combinations, right? So for example, if you have some characters 1 2 3 like this, the first combination can be 1 2 3 itself, and then it can be 1 plus 12 plus 3, then it can be 12 minus 3, then it can be 12 multiplied by 3, then it can be 1 plus 2 3, right, and so on. It will keep on going on. So these are all the combinations. So the first part of the question is to find all these combinations, and the second part of the question is to find whether the final combination that we have is equal to the target that we are trying to make, right? So these are the two parts of the question. So the initially how I was trying to do this was, for example, in at each place, what you can do is 1 2 3, let's say that you have, now you have already taken 12, right, 1 2 together. So let's say you are at position, this particular position. Now you have 4 possible combinations starting from this particular point, right? So all the 4 ways are, either you do 1 2 3 directly, or you can do 1 2 plus 3, or you can do 1 2 minus 3, or you can do 1 2 multiplied by 3, right? So similarly at each position you will have these 4 combinations. Either you can directly append the character, or you can append one of these characters first and then append that particular character, right? So at each position you will have 4 of these ways. So for example, you have 4 ways to deal with here, right? You have 4 ways to deal with here. You have 4 ways here, 4 ways here, 4 ways here, right? So the total like time complexity of forming all the permutations or all the combinations of these expressions would be 4 raised to the power n, right? Where n is the size of the string, or you can also write it as 4 modulo s, right? So this will be the total time complexity of forming these permutations, right? Now if I have one such combination, let's say 12 plus 3. So to evaluate this expression, I can just traverse through the string, right? If you are using something like Python, there is also a function like eval like this, but since we will be using C++ for this particular problem, we only have the string with us like this, right? So what we can do is, what I thought we could do was, we could just traverse through this string. But the problem is, this is very simple. The problem lies when you have the difference in precedence. So in this case, what I was trying to do was, in one traversal, I was trying to convert this infix notation into postfix notation. So it will be like 1, 2, 3 multiply and then plus, and I can easily evaluate this postfix notation and find my answer, right, for this particular expression. So although I thought this would work, because this whole process would collectively take, because we have to do 2 traversals of the string. In the first traversal, we will convert infix to postfix, right? And in the second traversal, we will find postfix to our current value, right? So this would essentially take 2 into n time, or 2 into s time, right? And the overall time complexity would have been 4 raised to the power s, right? This was the complexity of finding the permutation. So for each of the combination, I have to do 2 into s, right? So which is very close to the original expected time complexity. But I don't know why, unfortunately this didn't work at all, and it was constantly giving me time limit exceeded. So initially I was thinking that there must have been some problem while dealing with the substrings, because obviously in this particular case, while you have the initial string and you are doing some operations on it, we had a lot of operations on the string. So I thought that this operations on the string were causing really, because these operations are sometimes very expensive, but I tried everything and it didn't work. So now I had to somehow reduce the complexity. So obviously the complexity of the first part cannot be reduced, right? Because there is no other way to find all the combinations, and it cannot be done in a simple complexity. This is the only way. You have to go through all the possible combinations through recursion and backtracking, right? So this is the part I cannot reduce. The only part that I could have reduced is the second part, where I find the value of the final expression, right? So once we have an expression, we need to find its value and find out whether it is equal to a target or not. So I had to reduce the complexity of this particular operation, second part of my question. Now, interestingly enough, this question was formed in such a way that you could have evaluated this particular part, the final value of this expression, in constant time, right? So we'll discuss how we can evaluate this in constant time, and this is very clever. So what do we do is, let's say we have an expression like this, consisting of only plus and minus, right? We have no multiplication, let us assume for now. So if you want to evaluate this expression, what will be the value of this expression? So since associativity is from just left to right, simple. So you can just keep on adding 1 plus 2, then you add 3 to the result, then you subtract 5 from the result, then you add 7 to the result, and then you subtract 8 from the result, right? So you just have to go from left to right. But let's say you had something like this, then you have multiply. So what do we do? Now let us try to repeat the same process that we were doing here. So let me just also write something here also, right? So let us try to repeat the same process that we were doing in the first half in this particular manner. So what we do is, we do 3 plus 1. Good. So 3 plus 1 is now 4. Now we do 4 plus 2. So 4 plus 2 is now 6. But now we see we have a special operator that is not plus or minus, it is multiplication, right? So we know that if there is multiplication, I should have evaluated this part first. But instead, what I did was, I just added this 2 to this particular value, right? The value that was calculated from here, or it was equals to 4, right? So what I can do is, I can reverse the last operation, right? To reverse the last operation, I need to know two things. So I need to know what was the operator that was used. So if it was plus, to reverse the operation, I need to subtract some value. If it was, the operator was minus, to reverse the operation, I need to add some value. So let's say this was plus. So I need to subtract some value. What is the value that I need to subtract? It should be the last value that I have added that I need to subtract. So let's say we had 6. So I need to do 6 minus 2, and that will become 4, right? Now, since the last operation is reversed, 2 is now free to be placed here. So the last operation was reversed now. So now I can freely use this particular 2 with 3. Now I evaluate this particular part first. So I calculate it as 6, right? And then since the last operation was addition, my last operation will remain same. My last value will be updated by 6. So now the expression has become 4 plus 6. So this will be equals to 10, right? So let's say there was another multiplication here, multiplied by 3. So now I know that the previous operation that I did was plus and the previous value was 6. So I can easily revert the last operation by doing this, and it will be 4 again. So this part was 4. Now the last value was 6. I multiplied by 3. So it will become 6 into 3, 18. And then I can add it to my 4 value. So it will be 18 plus 4, that is 22. So you see, this way what we did was at the last stage you will observe that we did 4 plus 18, right? And this is exactly what we should have done. So if it is like 3 plus 1 plus 2 into 3 into 3, right? So this is 3 into 3, 9, 9 into 2, 18, and this is 3 plus 1, 4. So 4 plus 18, right? So this is exactly what we should have done, and it is coming out to be the same. So this is all about the problem, and let me just quickly summarize what we just discussed. So in the first part, what we need to do is we need to find all the combinations that we can form from the given input string S, right? So let's say the initial string was 1, 2, 3, and let's say we have already processed 1 and 2, right? Let's say we have processed this part. Now from here I can have 4 ways. Either I can attach directly 3 to it, or I can attach plus operator and then 3 to it, or I can attach minus operator and then 3 to it, or I can attach multiply operator and then 3 to it, right? These are the 4 possible ways that I have. Now what I need to do is, once I have calculated all the 4 possible ways and I have reached my final state, I need to find whether the value that I have for this particular expression is equal to the target value or not. So we discussed why it is not possible to calculate in O of n, because it was clearly given TLE. So the only other way was to calculate it in constant time. How do we calculate it in constant time? By calculating the value as along with going through the expression, right? While we were building our expression, we calculate the final value at the same time. So we noticed that if there are only plus and minus operators, it is very reasonable to just add our current value to our answer. But let's say we had some plus minus operators, 3 minus 1, let's say, and then we had a multiplication operator. So we see that this minus 1 was added to 3. So it would have been 3 minus 1, that is equals to 2. But I believe that this minus 1 should have been used with this particular operator first. So what I do is, I check what is the previous operator, I check what was the previous value, I reverse the operation. So how do I reverse the operation? If the result was 2 in this case and the previous operator was minus, so I need to add some value to reverse it. The last value was 1, so I need to add 1. So if I do this, my result will be 3. So this means I have reversed the previous operation. Cool enough. Now if I have reversed the previous operation, this particular 1 becomes free. Now I need to multiply this 1 with this particular 2. When I multiply this 1 with this particular 2, it becomes 2 itself, and then I can safely subtract this particular value from my result. So 3 minus 2 will be equals to 1. So whenever I encounter a multiplication operator, I just need to reverse the previous operation, and I need to take that particular value and do its multiplication with the current value and then redo the same operation. So if it was minus here, I have to do minus after multiplying 1 and 2, right? So this would be the solution of today's problem of the day. Now let me just show you the code. The code is also I believe a bit complex for this particular statement. So let us discuss what we are doing. So I have initialized my answer vector here, and this is my helper function. I will discuss it later on. Let's see what we are passing on the helper function with. So there are some values that I am passing to the helper function, and I am just calling it once, and after that I am just returning my answer. So let's see what are these values. So these values are actually taken from here. Let me just copy so that it is easier to read. So I'll be copying these values and writing it in a comment here. So the first variable is p. So this is going to be p. The second variable is the current expression. This will be the last, and let me just edit it first, and then I will show you. Right. So we have this particular thing. So the first value that I am considering is p. So p is the position in the original string s, right? And I am passing the current expression. So the current expression is the expression that I have calculated till now, right? And the last is the expression that will be the part of the expression that I am considering and I have not added it to my current expression. So it can be like, for example, let me just show you with an example as well. So if I have 1, 2, 3, right? So let's say I have 1 in my current. So my current expression is 1, right? And my last expression at one stage can be 2 and my last expression at one stage can be 2, 3, right? So this is the last number that I am considering, but I have not added it or I have not applied any operation to this to add to this current expression, right? So at the end what would happen is I have my current like this and I have my last expression like this. So what I can do is I can just append it to my current expression. So it can be 1 plus 2, 3 or 1 minus 2, 3 or 1 multiplied by 2, 3. It can take any of those forms, right? So last will be storing the integer that I have not added to my current expression. Here added means added means not literally addition. It can be also multiplication or subtraction, right? It can be any of those operations. It just means that I have not used this number yet. So my last operation, this will store whatever the last operation I performed. Since initially I am just passing an exclamation mark so that it is not equals to one of the valid expression. All the valid expressions are either multiply, plus or minus, right? So last value will be storing the last value that I have performed an operation on. As I have already discussed, that will be needing this particular value, and rest will be storing the result of the current expression. So what we have here is, this is the base case. We'll discuss it later on. Let's see what is here. I am adding the current character to my last variable, right? So what I'm essentially doing is, what is the current digit? I'm appending it to the last at the end of the last variable. Now if last is not equals to a single zero, why am I considering this particular case? So when last is not equals to 0, what I do is I just move on to the next iteration, p plus 1, and all the values remain as it is. So what is actually happening in this particular case is, this is the same operation when I had 1, 2, right? So I decided to go 1, 2, 3, right? In the example I discussed this particular thing, that I initially had 1, 2, and I just directly tried to append this particular value to my answer. So the next value will become 1, 2, 3, right? This is what we are doing in this particular operation. But what if last is equals to 0, right? If last is equals to 0 itself, then I cannot move on further, because in this way I cannot append 0 and I cannot have any values after it, right? So if the first character or the only character is 0 itself, then I cannot use this operation, because in this particular operation what we are doing is, we are taking the current character and we are appending some values after it, right? So if I only have 0, I cannot move further, because I cannot append any value for after it, because we are not allowed to take leading zeros, right? So that is why I have implemented this particular condition. Now I initialize 3 strings x, y and z, and I initialize all of them with current, right? So if x dot size is equals to 0, that means that I have not taken any of the expressions till now. My current expression is empty. So in this case, what I do is I move on to the next iteration. These are all the cases. So in this particular case, I decided that I don't want to add any operator in between, and I just want the next character. So this is that particular part. Now in the second part, what we are doing is, we are trying to add some particular operator to our answer. So if the current expression is itself empty, then we cannot add any operator to it, because for example, let's say we had a current expression like this. So this is nothing in this particular expression, right? And now we have our last expression as 1, 2, right? So since there are no things before it, it is reasonable to not add anything here, and then just directly write 1, 2. If let's say there was 1 here and there was 2, 3 here, then I would have explored all the 3 ways by adding plus, minus or multiply, right? So this is what we will be doing in a while now. But here you see that since the current expression is empty, that means we have not taken anything till now. So that is why I just mark my current expression as last, right? And my last will now become empty. So what is basically going on here is, my current expression is empty, my last was 1, 2, so I am switching it here, and I am marking my last as empty, right? So now my current expression will become 12 and my last will become empty, right? This is what is happening here. Now since I have done is, the last operator that I have taken will still become exclamation mark, because I have not taken any operators till now. The last value that I have taken will become equals to last, and my result will become equals to last, right? Because this is the only value that I have taken till now. Now in the other cases, when there was a previous expression before, so I have 3 ways. Either I can append plus and then last, I can append minus and then last, I can append multiply and then last, right? So these are the three possible ways. So I need to explore all of them. So in case the next operator is plus or minus, I don't need to do anything. I can just go to the next position. I can just use x. So this will be my new expression. My last will become empty, right? Since I have already appended last to my current expression, my last will become empty. My last operator will now become plus, and the last value that I have taken will become equals to last. So I am using STUL. This will convert my last string value into my long value, and then I'll add my last value to my result. Similarly, I can go to the next position and then take the new expression. My last will become empty. I'll mark my last operator taken as minus. I'll mark my last value taken as last, and I'll just subtract last value from my result, right? But now comes the interesting part. When the operator that we are choosing is multiply, right? So if the last operator is minus, so I need to reverse the operation. So what I do is I just do result plus last value. Now since I need to do multiply, I just multiply last value with the last current taken value, right? So I just subtract it to like redo the operation, and I just go move on to the next operation, right? So in this case, the updated value will be stored in rest since I have already updated it here, and the last operator will remain the same. The last value will get updated because with this particular value, right? Since I have already multiplied by with my current new value. So this is the updated expression, and last will again become empty. Similarly, if I have the plus operator, I just reverse the last operation that I made, right? So I just multiply this last value that I had taken with the current value that I am taking, and then this is the I'm just redoing the operation by again adding it to my result and just passing all the same things, right? So if neither of them is true, that means last was a multiply operation. In this case, I don't need to do anything. There is no problem with the precedence. It is now you see that this particular part is exactly similar to this particular part, right? I have taken p plus 1 and I have taken z because this was the expression for multiply. I have taken an empty string, then I am taking the last operation. I am converting the last into like integer, and I am multiplying. Here I was adding, here I was subtracting, here I am multiplying. So you see, when there is no problem of precedence, then I can just simply do this operation. Otherwise, I check whether there was an issue with the precedence. I update the values and I just move on further, right? So this was all about today's problem of the day. So while explaining the problem, I forgot to talk about this base case. Although it is not very difficult, I thought why not just talk about it quickly. So what do we do here is we just check whether p is equals to s dot size or not. That means we have reached the final positions and there are no more characters, right? That means this would be our base case. Now if last dot size is equals to 0, this means that there are no elements present in the last string, like that we were taking and are yet to be appended to the current expression, right? If last dot size equals to 0, that means all of the characters have been appended to the current expression. Now along with this, if the result is equals to our target, that means this is a valid expression and the total value is equals to our target, we just push back into our answer, and in any of those cases, even if it is not true, we can just return from here because this is the last position. I know that this problem was a bit lengthy and complex and it might have been difficult to understand, but I hope that this video was helpful for you. And if you guys were able to understand the solution, then do consider dropping a like on this video. And I see a lot of people who watch these videos are not subscribed yet. So if you're one of them, consider subscribing to the channel. It's always free of cost and you can always subscribe if you want to find the videos interesting later. So let me just quickly submit this problem and show you before signing off. So you see that this passes all the test cases and this solution is absolutely correct. And share this channel with your friends. Keep coding. Stay safe. Bye bye.